Okay, in this video we are going to be discussing how do we actually find the area of a region given a particular curve. So in this particular problem we are looking for this region right here. What is the area of that region? Now it's normal geometry. You have a known region and you need to use your known formula and you can find the area. But when you have an unknown shape like this, or any shape defined by any function, we want to be able to find the area under the curve. Well, that's where integration becomes very powerful for us. So what we're going to do here is we're going to take the integral from this x value to this x value. So the integral from 0 to 4 of our function, whatever the function of our curve is. So in this particular example, we are looking for this curve right here, which is going to give us, when we integrate from 0 to 4, it will give us the area under that curve, or I should say the area between the x-axis and that curve. So if we put that in here, we have 4 minus x, and then we have x plus 2. And so before we actually integrate this, we need to rewrite it a little bit differently. So we're going to expand here each one of these and each one of these. So the first two are going to give us 4x, and then this is going to give us plus 8. Then we're going to have minus an x squared in there, and then the last two are going to be minus 2x, all of that dx. Now when we simplify a little bit just by combining some like terms, we're going to have 0 to 4. I'm going to write them in order from largest power to smallest power. So there's minus x squared. Now we have 4x minus 2x is going to be plus 2x. And then we have a plus 8 here at the end. Okay, so now we are ready to integrate this one. And it might be helpful for us to remember this is really minus 1 or negative 1 x squared. So when we integrate, that's going to give us negative 1 x to the third over 3. That's the integral of this one. Plus x squared, 2x squared over 2 plus 8x. And I'd like to make this look a little bit nicer, so it's going to be minus 1 over 3 x to the third. 2 and 2 will cancel, so leaving us with plus x squared plus 8x. Now, because this is a definite integral, we know our x values here. We can say we are doing this from 0 to 4. So let's go ahead and see what that is going to become. We have minus 1 over 3 something to the third power plus something squared plus 8 times something. All of that minus the same thing again with this 0 plugged in. So it's going to be 1/3, that's a minus 1/3. Minus 1/3 to the third, something to the third, plus something squared, plus 8 times something. You don't need to write all these times somethings if you can go ahead and just plug in the value along your way, but I kind of like to do this. I think it helps people to see what's actually going on. So we plug in the 4 to each one of those, and then we come and we plug in the 0 to each one of those. And so now we just need to simplify a little bit here. And so what is this going to become? This is going to be, well, let's start here at the end where the easy part is. We have all these being zeros, so we're going to have a minus 0 at the end. This looks like it's going to be 32. This is going to be 16. And then here we have minus 1/3 times 4 to the third power. So that is going to be, this is 64 multiplied by negative 1/3, which is going to be negative 64 over 3. So now in order to simplify that, we are going to have negative 64 over 3 plus, this is going to be 48. So I'm going to do 48. This again can be done on your calculator, but I'm going to just do over 3 and over 3. So that's going to produce negative 64 over 3 plus 144 over 3, which is going to produce an area for us, which is going to be 80 over 3. Let me just put this over here. So it gives us as our area 80 over 3, or 26 and 2/3. So that means the area of this segment, this shaded region, is 80 over 3, or 26 and 2/3. Okay, let's consider this question now. Here we have the area of the region between curves. So here we are considering this region between two curves. Now we have this equation here that's given to us, 4 minus 4x, and then we also have another one given to us. This the upper curve is 9 minus 3 minus 5x squared minus x to the third. That's what this upper one is. It says, and the curves intersect at -1 and 8, so this must be -1, 8, and this one over here must be 1, 0. Okay, so how are we going to do this? Well, when you want to find the area between two curves, we could write it, let's call this upper one f of x. That's what it's called on here. And let's call this lower one, this straight line, we're going to call him g of x. So if you want to find the area between two curves, you're going to do f of x minus g of x, where f of x is the upper curve and g of x is the lower curve. And in our situation here, they tell us this is -1 and they tell us this is +1 on the x-axis. So that means we're going to do from -1 to +1 on our integral of the top curve minus the bottom curve. Okay, so what is that actually going to mean for us? That's going to mean from -1 to 1 of f of x minus g of x. So I'm going to write f of x here, 9 minus 3x minus 5x squared minus x to the third. Let's change colors, and let's be very careful here that we put this in brackets, because that minus is going to apply to everybody here. So g of x is going to be 4 minus 4x. And then to make everything and make everybody happy, this is all being integrated with respect to dx. So let's simplify what is inside of those orange brackets. Looks to me like we're going to have, we have 9 minus 4 is going to be 5. We have minus 3x minus -4x. That's really going to be, let's just, we'll come over here and do that. That's minus 3 minus minus 4. Those are pluses. So that's really a +1. So plus 1x. And we've taken care of both of those. We've done the -4, we've done the minus -4. So then these two guys are just going to be here. So we have minus 5x squared and minus x to the third dx. Now, a common mistake in these problems is for students just to then, at this point, plug in 1 and -1. The important thing for us to note here is that we haven't actually integrated yet. So we need to make sure we always integrate in problems such as this. So let's integrate 5, and that's going to be 5x to the first over 1. Let's integrate 1x, and that's going to be x squared over 2. Let's integrate this, which is going to be minus 5x to the third over 3. And when we integrate this one, minus x to the fourth over 4. And we are looking at the values from -1 to 1. So let's get ourselves a little bit more room here. So what do we have then? We are going to have two expressions here. And we're going to say 5 multiplied by something plus something squared divided by 2 minus 5 times something to the third over 3 minus something to the fourth over 4. All of that expression minus some other expression, which is going to be 5 times something plus something squared over 2 minus 5 times something to the third over 3 minus something to the fourth over 4. Now when we come back, we are going to plug in our 1, our 1, our 1, and our 1. That's from here. And over here we're going to plug in negative 1, negative 1, negative 1, and negative 1. So what will that yield for us? That will produce a 5 plus a 1/2 minus 5 over 3 minus 1 over 4. All of that, and here's where a lot of students make sign errors, and I just about made one. That's going to be minus 5. This minus 1 squared is positive 1, so we're going to have plus a half. This minus 1 to the third is going to be minus 1, so that minus 1 and that minus there on the 5 are going to eliminate each other, leaving us with 5 over 3. And then this minus 1 to the fourth power is going to be a positive, so that's going to leave us with minus 1/4. And now we have an expression here. Again, this is something that you could do on your calculator, or something that we can just work out here on our own. Brackets. So in getting rid of these brackets, we're going to have 5 plus a half minus 5 over 3 minus 1/4 plus 5 minus 1/2 minus 5 over 3 and plus 1/4. So looking at what we have from there, let's actually go down. Looking at what we have from there, we're going to have 5 plus 5 is going to be 10. Plus 1/2 and minus 1/2 are going to go. And I notice that we have minus 1/4 and plus 1/4. Those are going to go. And so now I see here, and we've already dealt with those two. So that means we have minus 5 over 3 and minus 5 over 3, which is minus 10 over 3. So if we make this into 30 over 3 minus 10 over 3, that's going to give us 20 over 3, or 6 2/3. So what does this 6 2/3 mean? If we come back up here, that 6 2/3 is the area between these two curves. So that must be 6 2/3 units, whatever our units are going to be there. 6 2/3.